Okay, hello everyone. Welcome to exam prep party. So you all can hear me, yes? Just the last check.
Yes.
Okay, perfect. Good. So we will start our exam review, and first I will start with the problem solving questions, and then we will go over the multiple choice question, the unit 2 practice exam, okay? So as you can see here, we have a diagram of 5 kilogram block, and this block is freely sliding down a ramp. Please fill in the potential energy, kinetic energy, and the total energy of the block at each of the position below. Be sure to include the correct unit and show your work. Okay, so for solving this problem, we need to know what is the kinetic energy and what is the potential energy. Okay, so you already know that if the object, oh, oh, why? It was writing. Oh, my bad. Okay, so I don't know what's the problem. Okay, just give me 1 second. Okay, so now I installed my document camera. Okay, and you all can see the question. So we have a 5 kilogram. So and we are supposed to find the potential energy and kinetic energy. Let me just before solving this problem, let you know what is the potential energy and kinetic energy. Potential energy is the energy which is stored on the object, okay, which is equal mgh. So what does it mean? It means that if we have an object and this object is above the surface with the h meter, if you release this object means. So what does it mean? It means that the energy is stored in this object. How we can calculate? We can say that this object will have potential energy, which is mgh. So when the object is above the ground, it will have a potential energy, and this energy is stored in the object. So we call it mgh. So kinetic energy is 1 over m velocity squared. If the object does have a velocity, it means that it's carrying energy. Any moving particle which has a velocity will have a kinetic energy, and kinetic energy is 1 over m velocity squared. So we have a conservation of energy, conservation of mechanical energy. What is the mechanical energy, or E total? E total is potential energy plus kinetic energy. And if in the system there is no friction or no resistive force, the total energy, the total mechanical energy will be conserved. So it means that it doesn't matter at which location this object is above the ground, is on the ground. If it does have a total energy, this total energy will be equal at any point. Good. So what does it mean here? Now let's start solving this problem. What is the potential energy? It is mgh. Okay, what is the m? M is the mass of the object, which is 5 kilogram time. We assume that the GE here is 10 meter per second squared. G is going to be 10. What is the height here? 300. 300. When you multiply these three numbers, what you get? It's going to be 15,000. Okay? So the object is at rest at the beginning. So when the object is at rest, it means that there is no kinetic energy. The entire kinetic energy is zero. So kinetic energy will be zero. What was the total energy? Total energy is potential energy plus kinetic energy. It means that we are supposed to add these two numbers. 15,000 plus 0 is going to be, again, 15,000 joule. Okay? So I will try to put all these 15,000 in anywhere. You remember I said that we have a conservation of mechanical energy, the total energy of the object, it doesn't matter at which location it is, okay? So it will be always constant. If here is a 15,000, here will be 15,000, 15,000, 15,000. Yes? Okay? So let's do the second one. When the object is 200 meters above the ground, I can calculate the potential energy. Potential energy is going to be mgh. What is the m again? Is 5, g is 10, and then h is going to be 200. When you multiply all these, it's going to be 10,000. Okay, how we can calculate the kinetic energy here? How we can calculate? So because we know that the total energy is 15,000 and the potential energy is 10,000. What would be the kinetic energy? 5,000 joule, okay? So, or you can subtract total energy by potential energy, it give you 5,000 joule. So now potential energy plus kinetic energy 10,000 plus 5,000 is going to be 15,000. Okay. Do the potential energy for the when the object is 100 meters above the ground. Again, mgh, m is gonna be 5, g 10, and the h is gonna be 100. Sorry, 100. Yes. When you multiply these numbers, it's gonna be 5,000. So potential energy is 5,000. What would be the kinetic energy? 10,000, because if we add potential and kinetic, it will give us the total energy, which total energy 15,000. So kinetic energy will be 10,000. Okay, what is the unit? We forgot to put the unit. Joules, joules, joules. Don't forget to put the units. Okay, now the object is on the ground. When the object is on the ground, potential energy is zero because it's not above the ground, okay? So potential energy is zero. It means that the entire energy turned to the kinetic energy, okay? So the total kinetic energy is going to be total mechanical energy. So conservation of energy. What is the conservation of energy? Energy is not created or not destroyed. It's transferred from one form to another form. For instance, here we have a potential energy, the entire potential energy, okay, here is the total mechanical energy, but as it's moving down, this box is going through the incline path, the potential energy decrease and then kinetic energy increase until the entire potential energy turn into the kinetic energy. Okay. So let's move on to the next problem. So I'll just give you 1-2 minutes to read this problem and try your best to see that you can go over the problem or not. Okay. So, yeah, just think about this problem for 2 minutes. Okay, let's go over this problem. And here we have a ball with a mass of 1 kilogram is tossed from a cliff and has an initial velocity component of 60 meters per second, which is vertical. You know, it's telling that this vertical component is 60 meters per second. And the horizontal velocity is 10 meters per second. The location of the ball is shown 2-second interval. So it means that from here to here is the 2-second interval. Okay. So air resistance is negligible, and you are assumed to just consider G as a 10 meter per second squared. So draw in velocity component vectors for horizontal and vertical component at each position. We know that in the projectile motion, okay, the horizontal velocity is going to be always same. So if here is 10 meter per second, this is going to be 10 meter per second, 10 meter per second, 10 meter per second, 10 meter per second. You know, you just need to draw exactly the same size. If it would be different size, probably your instructor give you the deduct some point. 10 meter per second, if you draw, when you are drawing, you should draw exact the same length. (10 meter per second), 10 meter per second. So what does it mean? We just go and write everywhere for Vx is 10 meter per second, 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 10 meter per second. But the y component, we know that the y component, the velocity, you know, because we in a projectile motion, we just convert one-dimensional motion to two one-dimensional motion. In the x component, the velocity is constant. In the y component, we will have a, when the ball is going up, it's going to be slowing down. When it's moving down, it will be speeding up. Okay, so what is telling that the time interval is 2 seconds. We know that when we throw the ball vertically, so the velocity for each second will reduce 10 meter per second. Okay, because from here to here is 2 seconds, 60 meter second will be 40 meter per second. 40 meter per second. So we are supposed to draw 40 meter per second. If let's say if this is 1, 2, 3 top part, we need to draw 40 meter second is going to be smaller than 60 meter per second. Good. It's going to be 40 meter per second. So 2 seconds later, again, another 20 meter per second will reduce, the velocity reduce another 20 meter per second. So it's going to be 20 meter per second. So it's going to be 20. Good. So the next 20 second, 2 second, okay, is going to be 0. So it means that the y component, the velocity here at y component doesn't have any value. Okay, the value is going to be 0. But when it's going down, the velocity is going to be exactly, you know, when they are at the same position. See here, when they are at the same position, the velocity is going to be exactly the same velocity, but opposite direction. Good. So, or you say that the velocity is 0, 2 seconds later, the velocity is going to be 20 meter second. Now, when you're dropping the ball, for each second, the velocity increased 10 meter per second. So, because it's 2 seconds, it's going to be 20 meter per second. So, what is this? It's going to be negative 20 meter per second. So, again, if this is 20, this is going to be negative 20 meter per second. So, this is 40 meter per second. This will be negative 40 meter per second. The same size vector, but in the opposite direction. Good. So when it's here 60 meter per second, so here is going to be negative 60 meter per second. If you don't put negative here, probably you will be deducted some point. Okay, you need to make sure that you are putting negative number here. So, and then this will be negative 60 meter per second, negative 40 meter per second, negative 20 meter per second. Okay. So write the value of the line. We already did part 2. Okay, it's telling that write the value on the lines for the vertical and the horizontal component. We already did that. Okay, and it's telling that how high is the ball's maximum height from its origin. So it's asking us to calculate this height, yes? So how we can calculate this height? You remember in the free fall, let's say we have a ball from here, yes? And the ball is moving down, okay? So, and reach to this point. What is the velocity on the top of the vertical velocity? 0, yes? The vertical velocity is 0. It means that you are dropping the ball. You can use the formula of the displacement, okay, with the constant acceleration, okay? So, which is yf yi plus viy delta t plus 1 over ay delta t squared. Good. If I simplify these, okay, so it's going to be h equal 1 over 2 gt squared, yes? What is the h? H is going to be this height or this height. And then how many seconds is from here to here? 6 seconds. Okay, so h will be 1 over 2, 10, 6 to the power of 2. So what is the height then? 180 meter, okay? This is part 3. Okay, so we are done with this practice problem, okay? Now go ahead and open your quiz practice review. And then we can just start working on those problems. Okay, so go ahead and just open your practice review quiz. So the question number 1 is telling that the difference between impulse and impact force involve the difference between impulse and impact. Oh, yes, the difference between impulse and impact force involve. Which one is the right answer? What do you think? We know that the formula of the impulse is F times delta T equal to changes of momentum, yes? Okay, so it means that it just time and the force which is acting on it, okay, that would be involved, okay? So the right answer will be this one, okay? Time, the force, act. So move on to the next problem. The two objects have the same size and same shape, but one is much heavier than the other. When they are dropped simultaneously from a tower, they reach to the ground at the same time, but the heavier one has a greater but the heavier one has a greater. Two objects have the same size and same. Oh, I don't know why it's copied 2 times. Okay, so so two objects have the same size, same shape, but one is much heavier than the other one. When they are dropped simultaneously from a tower, they reach the ground at the same time, at the same velocity, but at different. What do you think? What was the momentum? You remember what was the momentum? Let me just write it down. Every time I have to. Okay. The momentum is P equal mv. Yes? If the two balls have the same velocity, but the mass are different, let's say m1 is bigger than m2, based on this formula, yes? Okay, if we write P1 equal M1 V1 and P2 equal M2 V2, because V1 and V2 are equal, if the M1 is bigger than M2, definitely the momentum for one would be bigger than momentum P2. Good? So it means that if we come back to this question, which one is the right answer then? Momentum. Momentum will be the right answer. Okay, so this one will be the moment.
Is it for the party?
Yeah, it is for physics 120. Good. So what is the next problem? A bullet is fired from a gun. The speed of the bullet will be about the same as the speed of the recoiling gun. Okay, so which one is the right answer? We just explained that, yes? The recoil should be the same. If you want to have the recoil, at the same speed of the recoil gun, okay? So it means that if the mass of the bullet equal to the mass of the gun, they will have the same recoil. If the mass are different, definitely they will have the different recoil, okay? So different impulsive force. So the right answer for this question will be part 1. Question number 3. Recoil is noticeable if we throw a heavy ball while standing on rock. Escape if instead we go through the motion of the throwing the ball but hold on onto it, or net recoil will be 0. The net recoil. Okay, so what does it mean, the net recoil? Let me just explain here. When you have, let's say, this is a ball, yes? The ball come and reach to the wall, okay, exerted force on the ball, yeah, on the wall, and then the wall exert exactly the same force on the ball, yes? Okay, what would be the net force here? 0. So the net force will be 0. That's why in this problem, the answer will be 0. Okay. So the force that accelerates rocket in outer space is exerted on the rocket by so the reason that the rocket is moving is because of you remember the force, exhaust force, yes? Okay, here the reason that the rocket is traveling out of the space, okay, is because of the exhaust gases, yes? Exhaust gases. So the second part is going to be the right answer. Okay, question number 6. So I don't know why this printed 2 times, but which would be more damaging? Driving into a very massive concrete wall with no give, or having a head-on collision at the same speed with an identical car moving toward you with the same speed? Which would be more damaging? So which one? Car, wall, both the same, impossible to predict. Hmm? Car. So because we don't know any information about the cars, okay? So if we had information about the cars, that would be good, okay? Because it's telling that driving into very massive concrete or having a head-on collision at the same speed with an identical car moving toward you with the same speed. Because we don't know how much force will be exerted. How much force will be exerted when you have a head-on collision with the wall, or how much force will be exerted when you have a head-on collision with the other, the same car. So it means that it is impossible to predict. So this is going to be the right answer. Question number 7. A fan is attached. An ice sailcraft stalled on a windlass day blows air into the sail that bounces backward upon impact. The boat can move in the direction of the wind impact force, then move but in the opposite direction of the wind impact force, not move by this impact. So which one is the right answer? The first one is make more sense. Move in the direction of the wind impact force. Yes? Okay, based on Newton's second law, sigma F equal ma, yes? Okay, if you are exerting force, the object will be accelerating in the direction of the force. The object will be moving in the direction of the force. Okay, that's why the part 1 make more sense. So, a golf ball moving forward with 1 unit momentum strikes and bounces backward off a heavy bowling ball that is initially at rest and free to move. The bowling ball is set to motion with the momentum of I don't know. So again, so let's read this problem one more time. A golf ball moving forward with 1 unit momentum and strike and bounce backward off a heavy ball that is initially at rest. Okay? The bowling ball is set to the motion, is set in motion with a momentum of. Okay. Sorry. So, do you think which one is the right answer? It will be more than 1 unit is the right answer. But how? Let's me just show you. Okay, 1 kilogram meter per second, yes? And this one, no momentum. Okay. After collision, let's say this is a collision question, yes? After collision, we would like to see what happened exactly to the momentum of the bowling ball, yep? So, and if we assume that this one, the big one, 1 kilogram is reaching to the big one with heavy mass, is not moving, but we assume that this one gets velocity, but the other one will be reflected back, yes, bounce back. Okay, but we don't know what is this velocity. Good. So we calculate the momentum. What is the total momentum before collision? No, 1 kilogram. Okay, 1 kilogram plus the momentum of this one. You know, this one is a 1, this one is 0. 1 plus 0 is 1. But what is the momentum of the after collision? P after is going to be momentum of the big one, yes? Good. Plus the momentum of the small one, yes? This is the momentum of the small one. Let's call this big. This is a small object. Okay. So it's going to be what? P big plus minus P small. Why minus? Because it bounces back. Okay. Because this is bouncing back. We need to, because the momentum is the vector, we need to consider with its sign. Okay. When we are adding the total momentum, we should add with its sign. Good. So, and we know that the PI is equal PF, conservation of momentum, conservation of momentum, yes? PI equal PF. What was the PI? 1 equal. What is the PF? P big, yes. Plus minus is minus, yes. P is small. Okay. So, good. So what does it mean? P big minus P small is gonna be 1, okay? So it means that it might get more than 1 unit momentum, yes? Okay, that's why, because when you subtract these two, it's become 1. It means that one should be bigger than the another one, okay? Yes, okay, so that's why, the right answer will be more than 1 unit. Okay, question number 9. Let me just make this small. I use the half of the screen for the board. The other half I can write, the rest is good. I will write. Okay, perfect. Double this. Okay, so which question we are now? 9. Okay, perfect. So question number 9 is telling that a sandbag is motionless in outer space. A second sandbag with 3 times mass moving 12 meters per second collide with it. They stick together and move with what speed? So again, we are supposed to use the conservation of momentum, yes? PI equal PF, yes? It's telling that a sandbag is motionless, a second sandbag it is, okay, so let's say this sandbag is motionless, the second bag is 3 times, okay, 3 times bigger. If this is M, this is 3M, yes? Is moving with 12 meters per second, okay? And after collision, they stick together 3M. Stick with the M, and they both move with the same velocity. Good? So we need to calculate the PI first. What is the PI? This one doesn't have any momentum because the velocity is 0, okay? 0 plus. This one has a momentum. How we can calculate the momentum? Mass times velocity. Good? What is the mass? 3m. What is the velocity? 12. Mass times velocity is going to be 36 m. Okay? So what's going to be the total momentum? The initial momentum is going to be 36 m. So after collision, they stick together and they will have the same velocity. Okay? So it means that 3m and m is going to be one united mass, 3m plus m time to the same velocity. Okay? So, and then we know that the pi should be equal pf, conservation of momentum. What is the pf? Pf will be 4mv. Now plug these two equal to each other. So what is the pi? 36m. What is the pf? 4mv. Okay? M and M cancel each other, divide both sides by 4, divide both sides by 4. V is going to be 36 divided by 4 is going to be 9 meters per second. Okay? So what is the right answer then? The right answer is, it will be none of the above. Okay. Next problem. If you push an object twice as far while applying the same force, you do same work, 4 times as much work, half as much work, twice as much work. So what is the formula of the work then? Work is equal to force times displacement. It's telling that if you push an object twice as far, so if you are pushing the first object d meter and then the other objects 2d meter, yes? So with the same force, what is the work for the first one? W is force times d, yes? What is the work for the second one? Is again force time. What is the displacement? 2d. Okay? So if we call this W1 and if we call this W2, it's going to be 2FD. Okay? So W1 is FD, W2 is 2FD. What does it mean? It means that W2 is 2 times of the W1. So which one is the right answer then? Yes, twice as much.
Yeah, like.
So the right answer is going to be twice as much as what? Twice as much.
Yeah.
So 11.
Well.
Okay, 11. 200 joule work in 50 seconds. And what is the power? What is the power formula? Power is work over time, yes? So what is the work? 100 joule over what is the time? 50 seconds. So 100 divided by 50 is 2. 2 joule per second or 2 watt, yes? So the right answer is going to be 2. 12. When bullets are fired from airplane in the forward direction, the momentum of the airplane will be
It's more like the way. Yeah, so find the animal. That's connected. Let's say to the-
okay. When bullets are fired from an airplane in the forward direction, the momentum of airplane will be unchanged, increase, decrease. What do you think? If we want to have a conservation of momentum, if something is fired from the airplane which will have a momentum, so it means that the momentum of the airplane should decrease, yes? Okay, because when we add these two, the momentum should be conserved. So the best answer is decrease. Make sense? For those who are in the at home, okay, so if any time that we need explanation, please let me know. Okay, I will try to explain more. My chat box is open. You can type your question in the chat, or you can unmute your microphone. So number 13. After rolling halfway down an incline, a marble's kinetic energy is halfway down. What do you think? The marble kinetic energy is going to be the same as potential, less than potential, greater than potential, and impossible to determine. Exactly. Yes, it is same. So why? Okay, let's say if we have a potential energy on the top.
So basically,
Good. This is the entire total energy. In the middle, okay, the middle, if this is a height and this is a half a height, the momentum, the potential energy become half, yeah? What happened to the other half? It's going to be kinetic energy, yes, okay? The other half turn to the kinetic energy. So it means that potential and kinetic energy at the half point are equal. So the right answer will be the same as potential energy. Number 14.
yeah, like that.
This.
So it's a lot of thinking. I don't have a lot of background in physics, so.
So number
That's the biggest thing right there. I need my help.
number 14. So a ball is rolling down
That was.
an inclined plane. An incline has its momentum speed half the way down the incline. At the end the incline, near the top of the incline, impossible to predict work without knowing the ball mass, and impossible to predict without knowing the size of ball. Which one? A ball rolling down an incline has its minimum speed near the top of the incline, yes? Okay, so incline, so what happened here? Let's say if you have an incline, the ball would have the velocity and goes and then reach this point and then come back. So it means that when the ball changes its velocity, okay, change its direction, it means that its velocity become almost zero. That's why it's changing the velocity. When the velocity decreases, though, the momentum will have its minimum. Good. So what is the right answer? The right answer will be near the top. near the top, okay, it will be the right answer. So which question we are now? Question number 15. A 2 kilogram mass is held 4 meters above the ground. What is the approximate potential energy of the mass with respect to the ground? Okay. So what was the potential energy's definition? Potential energy is equal mgh. What is the mass? The mass is 2 kilogram, yes? The mass is 2 kilogram. The G is 10 and the height is 4. So when you multiply these, 2 times 10 is going to be 20. 20 times 4 is going to be 82. Good. So what is the right answer then? 82.
Yes. Okay, yeah.
Question number 16. A car moves 4 times as fast as another car. Let's say we have 2 cars, yes? This is V, the other one is 4V, yep? Compared to the slower, the faster has, what happened to the kinetic energy? So we know that the kinetic energy 1 over 2m velocity squared, good? If we quadruple the velocity, instead of velocity, we need to put 4v squared, yes? So 4v squared will be 1 over 2m 16 velocity squared. Okay, when you simplify it, if you simplify this or write like this, okay, 16 times 1 over 2m velocity squared. So what happened? The kinetic energy of the car, which has the v velocity, is going to be 1 over 2m velocity squared. When you quadruple the velocity, the kinetic energy, will be 16 times bigger than the kinetic energy of the first car. So the right answer will be 16 times bigger. 17. So a car moving with 50 kilometer per hour, okay, the car moving with the 50 kilometer per hour, 50 kilometer per hour, skid 20 meters. So it means that its stopping distance is 20 meters. How far the car skid? So it means that what is the stopping distance, new stopping distance, if the velocity of car become 150 kilometer per hour? Okay, 3 times bigger. Hmm? 20 times no, because the stopping distance in the lab, you have found that the stopping distance is changed with the velocity squared, yes? Is directly related to the velocity squared. It means that if velocity double, okay, if velocity triple, your stopping distance would be 9 times bigger. Okay, so see, the velocity, how many times is bigger? 3 times. So if the velocity become 3 times bigger, you see what happened to distance? Stopping distance is going to be 9 times velocity squared. Yep, 9 times bigger than this stopping distance. If the stopping distance is 20, okay, when the velocity is 50 kilometer, if you triple the velocity, Good. Stopping distance, you know, we triple the velocity, v changed to the 3v, it's become 9v squared. So it means that d, this new d, let's call d2, is how many times bigger than d1? D2 is 9 times bigger than D1. So what was the D1? 20. So D2 is going to be 180 meter. So what is the right answer then? 180 meter is going to be the right answer. Okay, so I'll be back, okay, in 1 second. I'll give you just 5-minute break, okay? So I'll be back in 5 minutes. 18. Okay, so Jack, a jack system will increase the potential energy of a heavy load by 1000 joule with a work input of 2000 joule. Okay, so the efficiency of the jack is how much? So it is clear that the efficiency here is how many times bigger? You know, because it was, you know, 100,000, sorry, 1000 joule, and then the work of input and the work of, okay, so output is 1000, input is 2000, yes? So work out, work in, yes? Work out is 1000 joule, work in is 2000 joule. When you divide this, it's going to be 1/2 or 0.5. When you multiply by 100, it's going to be 50%. So the 50% is going to be the right answer for this question. Question number 19. We need to go a little fast. Okay, how many joules of energy are in the kilowatt hour? Okay, 1 kilowatt, you know, 1 kilowatt per hours. Okay, and what is the power? Power unit is joule per second. Okay, good. How many joules are in 1 kilowatt hour? Okay, so what is the right answer here? We need to do some unit conversion here. Okay, so because 1 joule per second is 1 watt, yes? Okay, 1 joule per second is 1 watt, and 1 kilowatt per hour, we can write, you know, we convert the kilowatt to the watt, so it's gonna be, it is, this one is 120. So do you have, okay, so we are done in 20 minutes, 15 minutes. Okay, so, okay, 1 kilowatt per hour. So, and how we can just convert this? We know that 1 hour is 60 minutes, yes? And 1 minute is 60 seconds, okay? And then 1 kilowatt is 1000 watt. Okay, so kilowatt cancel each other, hour cancel each other. So minute and minute cancel each other. Good. So what happened here? We will have, you know, 1000 watt over 3600 seconds. Okay. So if we flip this, okay, 3600 600 to 1000 is going to be 3.6. Okay, so let me just see how many joules of energy are in 1 kilowatt per hour. Oh, okay, so we need to do this. Sorry. So my calculation was right. Okay, so just do this. 1 kilowatt per hour. Okay. Is telling that how many joules of energy are in 1 kilowatt per hour. We need to just say that 1 kilowatt. 1 kilowatt, 1 kilowatt. 1 kilowatt is 1000 watt, yes, per hour. Okay, let me just think about this. What is the power? Joule per second, yes? So it means that if your power is going to be energy over time, yes? Multiply time both sides, yes? Okay, the energy, which is going to be joule, is going to be power multiplied by time, okay? Okay? So, we already have the power. Power is 1 kilowatt per hour. We need to multiply this by time, okay? So, we can say 1 hour is how many seconds? 1 hour is 3600 seconds. So, instead of multiplying 1 hour, we just multiply by 3600 seconds, yes? So it means that this time and this time cancel each other. 1 kilowatt is 1000 watt, yes? 1000 watt time 3600 second, yes? And what was the unit of the energy? It was watt per time second. Good. So when you multiply these two, it's going to be 36,020. So it's going to be 3.6 million. Okay, the right answer will be RC. Okay. Question number 20. So when a rifle is fired, its recoil as the bullet is set in motion. The rifle and bullet ideally acquire equal but opposite amount of momentum. Yes? Equal but opposite direction. Okay, they will be equal but in the opposite direction. The right answer will be B. 21. A feather and coin drop in vacuum fall with equal. What is going to be the answer here? They reach to the ground at the same time. Same velocity. Good. So it means that same time, same velocity, it means the same acceleration. Yes? Okay, so when there is a vacuum, okay, they will reach to the ground with the same acceleration, but the force will be different. Kinetic energy, because they have a different mass, okay, so kinetic energy is 1/2 m velocity squared, okay? So they reach to the ground with the same velocity, but the kinetic energy will be different, okay? And the acceleration is the same. And so, yes, the right answer will be acceleration. So, question number 22, yes. A car has a head-on collision with another car that was approaching with the same magnitude of the momentum. A third identical car driving with the same speed as the first car ran into an enormously massive wall. Which of the four objects will experience the greatest impulse? A car has a head-on collision with another car that was approaching with the same magnitude of the momentum. A third identical. Oh, okay. Yeah. I'm just reading too high. Okay, sorry. Yeah, which one?
So the ticket measure was not on both sides of the data.
They all receive the same impulse because the changes of momentum for all it will be same. Good? Because the impulse is equal to changes of momentum. See, we have a feedback for this question. Changes of momentum is going to be equal to the impulse because the changes of momentum for all will be the same. They will be experiencing the same impulse. Okay? So the right answer will be all receive the same impulse. So next question. So two 5,000 kilogram passenger cars roll without friction, one at 1 meter per second, another one at 2 meter per second toward one another on a level track. They collide, coupe, and roll away together with combined momentum. So, what is the combined momentum? So, again, momentum before should be equal momentum after. Yes? What is the momentum before? We have, 1 kilogram, 1 meter per second. One is 1 meter per second. The other one is 2 meter per second. So it means that PI is going to be 5,000 kilogram. One is moving with 1 meter per second plus another 5,000 gram is moving with 2 meter per second. Good. So, and 5,000 times 1 is going to be 5,000. 5,000 times 2 is going to be 10,000. 5,000 plus 10,000 is going to be 15,000. Okay? So it means that PF should be equal PI. So what does it mean? The right answer is going to be 15,000. Yes? The final momentum is going to be 15,000. Next question. If several balls are thrown straight up with varying initial velocity, the quantity that will have the quantity that will have the same value for each trial is the balls. If they are moving with this different velocity, good, they will have the different height. Make sense? They will have, different time traveling to. They will have, different momentum because because all have the different velocity. So which one is the same? Which one is going to be the same? Just the acceleration. Yes, because the height will be different as well. Okay, so the same is going to be the acceleration. Acceleration for all will be same. Assume that there is no air resistance. Okay, if there is air resistance, that would be different story. Number 25. According to the Newton's law, the greater the mass of the interacting object, the greater mass. What was the formula of the force of gravity? G m1 m2 r squared. If the mass bigger, yes, force of gravity will be bigger. Okay, so which one is the right answer then? The greater the gravitational force between them. The greater mass, the greater gravitational force. (26) If your mass the mass of Earth and the mass of everything in the solar system were twice as much as it is now, yet everything is stayed same size, your weight and on Earth would be, if the size is gonna be the same size, yes, but if this everything is gonna be the same size, but what happened? How many times bigger? Twice as much as it is now, yes? If your mass and the mass of the Earth and the mass of the everything in the solar system were twice as much as it is now, yet everything is stayed same size. Okay, so what would be the force of gravity? What happened to the force of gravity? You see, force of gravity, G m1 m2 divided by r squared. If you don't change the r, good, the size is exactly the same size, good, but you change the mass of Earth and mass of the person. So what happened? If you just do the m1 2 m1, good, and then m2 2 m2, but the r stays same. If you multiply these two numbers, it's gonna be 4g m1 m2 divided by r squared. Good. So it's gonna be 4 times. Good. So what is the right answer then? It's gonna be quadruple. $27. A Weight Watcher who normally weighs 400 Newton stand on the top of very tall ladder, and so she's 1 Earth radius above the Earth's surface. How much would she weigh? So what does it mean here? So it means that if this is the Earth, you are standing on the Earth, good? And then there will be a ladder, and you are standing on the ladder, okay, which will be exactly the same. If this is r, the radius of the Earth is r, the distance from the Earth to the person is again r. Good? It's telling that if your weight here is 400 Newton, what happened to your weight when you are above the ground? With the same size above the ground, okay? So I know that for this situation, F is equal G m1 m2 divided by r squared, which is gonna be your weight, 400. But if you change this to G m1 m2, again m1, let's say m of the Earth, okay, m2 is the m of the person, m2 m of the person, m1 m of the Earth. M1 and M2 is going to be the same thing. But what changed here? The R is changing. The R changed to 2R. Okay? S squared. What happened here is going to be G M1 M2 divided by 4R squared. Good? So what was your weight here? 400. Okay? But your new weight here, see? F is 1/4 of the GM1 M2 over R squared. Yep. 1/4 of the 400 Newton is going to be 1/4 of the 400 Newton. What is your new weight then? 100, yes? F is going to be, okay. 28.
Okay.
The planet Jupiter is about 300 times as massive as Earth. The planet Jupiter is 300 times as massive as Earth. Yet on its surface, you would weigh only about 3 times as much as this, because your Jupiter radius is 10 times of the Earth. Your mass is 100 times. Okay, Jupiter is significantly farther from you are 100 times more weightless. Okay, so again, what is telling that? Let's say if I solve this, I just say like this. Okay, so if this is the m of Earth, m of Jupiter is how many times? 300 times bigger than mass of Earth. Yes. It is not 300 times. Okay, it doesn't show 300 times, but you assume that it is 300 times. Okay, it's bigger than that. And it's telling that your weight on its surface, your weight here is 3 times as much as the weight on the ground. Good. Your weight is 3 times weight on the earth. Good. So what exactly happened here? We know that again, F here is gm, mass of the person, mass of the earth, divided by r squared, r of the earth. Good. But the F here, your weight, new weight, is how many times? Is g, mass of the person, mass of the Jupiter, divided by radius of the Jupiter squared. Good. And it's telling that if your weight here is W, your weight here is going to be 3WE. Yep. 3 times bigger. Okay. So you already have WE. Go ahead and just plug it equal to this one. Okay. So WE, I just write it down here. 3GM, m of Earth divided by radius of Earth squared. And this is going to be GM, mass of Jupiter divided by radius of Jupiter squared. Good. So G cancel each other. Mass of the person cancel each other. Okay. And we already know that mass of Jupiter, see here, mass of Jupiter is how many times bigger than mass of the Earth? 300 times. So instead of mass of Jupiter, I just plug 300 mass of Earth. Good. So right now here, mass of Earth and mass of Earth cancel each other. What is left is going to be 3 over r squared equal 300 over r Jupiter squared. Okay? Okay, go ahead and simplify more. I just multiply these two. Is going to be 3rj squared equal 300 re squared. Okay? Divided by 3 is going to be radius of the Jupiter squared. It's going to be 100 times radius of the Earth squared. Okay? Take the square root of both sides. So when you take the square root, it's going to be radius of the Jupiter is going to be 10 times of the radius of the Earth. Yep. So what is the right answer then? Yep.
No, original philosophy, once I did the it's about 6 grade next time.
30.
Get a grade.
Oh, we are in 30 or 29? 29. We might be able to do until 30. Okay.
You need it. Do the integration of. Get the.
Yeah, there is a feedback here. Okay, so you can use the feedback. 29 is telling that the passenger in high-flying jumbo jet feel their normal weight in flight, while the passenger in orbiting space shuttle do not. This is because the passenger in a space shuttle is without, you remember, no support force. Okay, no normal force. No support force or no normal force. Question number 30. A supplier wants to make a profit by buying metal by weight at one altitude and selling it at the same price per pound at another altitude. The supplier would do what? So what is the weight? You know how the weight is changing, weight relation Gm1, m2 divided by r squared, force of gravity or weight. We call it force of gravity or weight. So the weight becomes smaller at the highest altitude, yes, and become bigger at lowest altitude, okay? So why? Because radius, the mass is the same mass, okay? But if you are selling it with weight, that would be different. R is gonna be R changing the weight. Okay, if you are 100,000th time, okay, if you are far away from the earth, definitely you feel weightless. Okay, so here the same situation happened. So it's better to buy at high altitude, good, and then sell it at low altitude. Okay, so 31. A rock is thrown upward at 50 degrees with respect to the horizontal. As it rises, horizontal component of the velocity unchanged. We already discussed about this. Okay, the horizontal velocity is gonna be remain unchanged. So number 32, roll a bowling ball at the edge of the table. It fall, its horizontal component of the velocity again. Yes. Horizontal velocity remain constant. 33, air satellite is simply a projectile. Yes. Which one is the right answer? Freely falling around the earth, because it's the free fall is happening. Okay, so the free fall is happening, but because this free fall is happening, is always orbiting around the surface. Yes. A gun with a muzzle velocity of no. Okay, sorry about that. Okay, a gun with a muzzle velocity of 100 meters per second is fired horizontally from a tower, neglecting air resistance. How far down range will the bullet be 1 second later? Okay, it's telling that we don't have, air resistance, yes, and the gun velocity is horizontally. You see, the horizontally, this velocity is 100 meters per second. Okay, and it's telling that 1 second later, good. 1 second later, let's say the gun is here. Yes? What would be, what the question is asking, how far down range? How far is moving? So it means that we are supposed to calculate the x component, yes, not the y component. What was the formula of the position displacement with the constant velocity? X equal velocity multiplied by time, yes? What is the velocity here? Horizontal velocity, 100 meter per second. Time, how many seconds later?
Dude, we had exam
1
right now.
second later. Okay, 100 time 1 is going to be 100 meter. So the answer will be 100 meter.
Probably asked. Physics 250.
You know, people said that, is it project or?
This is like one of the questions that might be names on. So it's just junk.
Okay, 35.
Thank you very much, Bill.
Are you, say, you can use a estimator pen?
No.
It doesn't test that.
No, just
Diligent, you expect that as, dense like. Number?
number.
Number.
Yeah.
Okay, so
Huh?
what prevents satellite such as a space shuttle from falling? Good. So this is going to be the last question. What prevents satellite such as a space shuttle from falling? So they are falling continuously all around the earth, yes? Free fall motion, okay? As long as they are orbiting, okay, we will have a free fall. Okay, so I have to end this.